The Fluke 810 vibration tester provides the easiest way to troubleshoot vibration issues and get instant answers to your most common mechanical problems, including problems with bearings, misalignment, unbalance, and looseness at the point of measurement without prior measurement history. The Fluke 810 will start saving you money right out of the box, reducing unplanned downtime as well as time and materials cost. Fluke 810's diagnostic engine reviews your machine setup information and vibration data against a vast database of similar machines, and by using a set of powerful algorithms, delivers text-based machine diagnosis and severity levels along with repair recommendations. With the included Viewer PC software, you can store your machine information and track a problem's severity over time. And unlike current vibration analyzers, the Fluke 810 requires no special training or major investment. This product demonstration will give you an overview of the Fluke 810 vibration tester setup and operation. See for yourself just how easy and effective it is. The Fluke 810 takes an easy three-step approach to determine machine condition: setup, measure, and diagnose. In this demonstration, we're testing a typical 20 horsepower AC motor coupled to a pump. Your setup may vary depending on your application. The first step is easy. After turning on the vibration tester, press the yellow Setup button. The 810 guides you through setup with a series of simple questions. First, select Setup New Machine. Then enter your machine name. To enter, you can either use the dial or the F3 soft key. The rotating dial makes it easy to select characters to enter a machine name. To move the cursor, use the F2 button. To delete, hit F4 or backspace. When you're finished, simply hit F5 and then F4 to move on. Once completed, the machine setup will be saved in the tester's memory for future measurements. In the machine setup, the tester will ask you to enter information about the motor, the transmission, and the driven component. As you answer these questions, the tester will build an image on top of the screen depicting the machine drivetrain. It's important to give accurate answers during setup. Guesses or estimates may result in a misleading diagnosis. For motor type, select AC. Select Yes if motor is VFD or variable frequency drive. Otherwise, select No. Entering the correct running speed is critical to an accurate diagnosis. The Fluke 810 ships with an integrated laser tachometer for measuring the running speed of rotating equipment. Before using the laser tachometer, make sure to turn the motor off. Affix a piece of included reflective tape to the drive shaft. Do not attempt this procedure while the machine is running. Once the tape is applied, return the machinery to normal operating conditions. Connect the tachometer cable to the first connector at the top of the tester. Hit F3, and when you see the green light on the laser tachometer, push the button and point the laser beam to the shaft where you want to make a measurement. Enter 20 horsepower for the motor's horsepower. Hit F3 or Enter. Follow the on-screen prompts to continue with machine setup. Select Horizontal for motor mounting. Select Roller for motor bearing type, and select No for motor detached from the drivetrain. If you're only testing the motor and there is nothing attached to it, select Yes. Select No for motor closed coupled. Yes for coupling between motor and next component. Select Pump from the combo box Next component. Select Roller for driven component bearing type, Centrifugal for pump type, and for impeller is supported by, select Overhung. All questions within the machine setup are required to generate a diagnosis, except those labeled Optional. Optional information is usually easy to obtain from the manual or the manufacturer and will help ensure a correct diagnosis. Skipping optional questions may result in an overdiagnosis of the component's condition or a false positive diagnosis. but if you choose to skip them, simply push F2 after you have answered all the required questions. For this demonstration, press F4 and use the dial to enter 5 for the number of vanes. Once you've confirmed your selection, the tester will go to the last setup screen. Press F3 to complete the machine setup. Now we're ready to take a measurement. Use the yellow Measure hard key to select a previous setup for measurement. On a variable frequency drive, it's recommended to re-enter the actual running speed value, as the speed will vary with the load. The numbers at the top of the drivetrain image indicate the measurement locations. Choose the first location and mount the sensor. Typically, rotating equipment will vibrate in 3 different directions or axes. The triaxial sensor can collect vibration signals from these 3 axes simultaneously. Sensor orientation screens help the tester understand from which axes vibration signals are coming. By testing certain points along the entire drivetrain rather than a single component, the tester can account for transient vibration from other sources and give you a more comprehensive diagnosis. The sensor needs to be located as close as possible to the bearing or on a solid structural member leading to the bearing. You can select any of these measurement locations to start. From these marked locations, you can place the sensor either at the top, bottom, side, or end. Take vibration measurements when the machine is running at a steady state and at normal operating temperature. All of the measurements must be completed within 30 minutes to minimize the risk of varying load conditions affecting the diagnosis. If the drive motor has more than 40 horsepower and is longer than 40 inches, it's recommended to take 2 measurements from each component in the drivetrain. Otherwise, 1 measurement from each component will suffice. Push Enter to select location number 1. For this demonstration, we first put the sensor on the motor's free end at the top, where the cable is perpendicular to the shaft. Whenever possible, place the sensor parallel or perpendicular to the shaft. Attach the sensor to a clean, flat, bare metal surface. Avoid thin surfaces like shrouds or uneven surfaces like cooling fins. Thick layers of paint, grease, oil, or other matter will reduce both the holding force of the magnet and the high-frequency response of the sensor. Take care when attaching a magnetically mounted sensor. Hold the sensor firmly and roll it carefully onto the test surface to prevent any jarring and potential damage to the sensor. Press F3 or Enter, or use the dial to select the orientation. In this case, we located the sensor at the top of the motor rather than the bottom, side, or end, and perpendicular to the drive shaft. Having completed the sensor orientation, we're ready to collect data. Push F3 to begin. Once that's done, push F4 to continue on to the next location. If the orientation of the sensor remains the same in terms of location and cable direction, hit Copy Last to use the last orientation information. It's important to use the same orientation each time you take measurements at any given location to maintain consistent diagnostic records. The tester also has onboard context-sensitive help to provide practical information on a variety of subjects, from sensor placement and orientation to interpreting the diagnostic output. After taking sufficient measurements on the drivetrain, press the F3 Diagnosed soft key to view diagnosis. It's as easy as that. The tester provides you with fast, text-based diagnosis of your equipment's condition, severity, and actual location of the fault. Interpreting the diagnostic severity scale is simple. For slight faults, no repair action is recommended. Monitor the machine and retest after regular machine maintenance to verify maintenance was performed correctly. For moderate faults, repair action will be needed in months, even up to a year. A machine failure is possible, so plan for it. Increase the frequency of vibration testing on this equipment and review spare parts availability. For serious faults, Repair action should be taken in the near future, during the next planned downtime or scheduled preventive maintenance. For extreme faults, it is recommended to shut down and take repair action immediately to avoid failure. By clicking on History, you can view the diagnosis that you received the last time measurements were taken and view the details of these faults. If you want to see details, hit F3 and view Cited Peaks. To view spectra, hit F2 to view in graphs mode. Repair Details gives you prioritized recommendations based on the 810's diagnosis. The Fluke 810 Vibration Tester will give you the information you need to make reliable maintenance decisions without wasting time and money. It's the easiest way to troubleshoot vibration issues and get the answers you need fast. For more information, go to fluke.com.